Okay, let's keep going. While I'm here, I'm going to go ahead and create some more rung comments. So this is going to be my drain mode. Let's go ahead and take that. Then I'm going to have my low alarm mode. So one more rung comment, LLALM mode. Take it, and then let's put our last mode comment in here so that we can look back at any time and know exactly what we're looking at. And that's going to be our high alarm mode. Gotcha. So now we've got that as a guide. And what else do we need to do in here? We need to jump back in now and create the conditions that are going to put us into drain mode. That's going to be our high level switch. So I'm going to come back over here to rung 6, and it looks like we have something that's still undefined. So let's go through here and look, and I bet it's our low switch. We haven't created that yet. So let's go ahead and make sure that's a bool and it's in our program scope. And then I'm going to copy this rung and paste it right here. And now we're going to just bastardize this and turn it into our high delay. So let's create that data tag. We've got it. And as long as we are not either off or in one of our two alarm conditions, then we want the high switch, not the low switch, being closed, not open. So we can just double click on the instruction here and change that from an XIO to an XIC. Then we just need to define the tag, and shabam, just like that, we've got one more timer down here already with the 5-second preset. And I can come up here and just create my XIC. That's going to be my h_delay.dn. And then let's throw in my one shot, and that's going to be an ONS4. Good enough. And let's create that as well. And just like that, we can now get into fill mode and drain mode, start mode and off. And now we just have to worry about our two alarm modes. And as you can probably guess, we're going to do the exact same thing 2 more times. So I'm going to copy that and just paste it twice. And down here, we're going to have a low, and we're going to have a high. Whoops, that's not where I wanted that H to go, so let's try that again. That's more like it. And actually, I got this one wrong too, so let's go back and fix it. So now we've got HH delay and LL delay. And I'll go ahead and create both of those. And I think a 5-second preset is pretty good on those as well. There's no reason that we would need to wait longer, especially if we're in a bad state of affairs. Let's go ahead and change this switch to a high switch. This is going to go back to being an XIO because we're moving down, not up. And this one will be our low. Actually, I think I've got those switched, don't I? Well, let's go ahead and just make that a low for the time being. And then I'll just switch those around because I kind of got confused while I was creating them in the first place. So now we've got the low switch being open and the high switch being closed. And now we just need to create those switches, both Booleans and both within our program scope. There we go. And this we want to evaluate anytime we are not in the opposite mode. So now let's look at our conditions for going into these modes. Well, we don't want to be in an alarm condition just because our system is off and maybe the tank is empty. So that doesn't make a lot of sense. So as long as the system is off, we want to make sure not to go into an alarm condition. But as far as these other two conditions already being in an alarm condition, it doesn't really make a lot of sense to be in one alarm condition and then to trigger another alarm. So let's go ahead and leave all of these conditions. If we're in an alarm condition, the only state that we want to be able to go to is off. And right now we can do that. Otherwise, if we're in an alarm condition, the only way that we'll be able to get out is if somebody hits an alarm reset button, or at least that's the idea. So I'm going to go ahead and come up here and put our actions onto our modes so that we're actually getting into those modes based on the timers that we just set. So for our low alarm mode, we're looking at our low delay timer being done. And then we're going to want our familiar one shot once again. And that's going to be ONS 5. And same thing down here. This is going to be our high delay timer being done. And we're going to need one more one shot on that as well. And would these work without the one shots? Yes, they would. But do we want constant control being exerted on our moves based on a timer staying energized all the time? No, we don't. So that's what these one shots are for. And these moves are just going to happen one time, and those are going to trigger us changing our mode. But that's not actually going to, control those all the time. That's only going to take an immediate action and then disappear. So now that we've got all these, let's go ahead and make sure to create the tags. That way we can get rid of our errors off to the left. Good and good. So now that we've got our modes laid out, we've got something that can trigger alarm conditions. The next thing that we have to do is worry about controlling our devices. We have our pump and we have our valve. So let's go ahead and create 2 more rungs here. And we're going to use our very familiar digital control logic. And you should know by now what that looks like. I'm going to put a branch here. And actually, I'm just going to delete this second rung so I can copy and paste this one later. We're going to have a trigger. Then we're going to have a lock-in or a hold-in. And then we're going to have an interrupt. And that's all going to work on our device. So this right here, we can copy and paste. That is the standard control format that you want to use when you're controlling a digital device. So let's go ahead and get these things filled out a little bit. This one's going to control our pump. So I'm just going to go ahead and put pump right there. This one's going to control our valve. So now we've got our 2 devices. Let's go ahead and create those 2 bools in our main program. Got them. And now we know each device is going to be its own hold-in because that's how digital control circuits work on here. So let's go ahead and just copy those 2 tags, punch them into the hold-ins, and then we're going to need a trigger for each of these. So what's actually going to trigger my pump coming on? Well, I want my pump to come on whenever I'm in drain mode. So let's come up here and check, and we see that our fill mode is state 2. So we need a trigger based on state 2. So let's go ahead and put one more rung in here under that. And we're going to pull up a comparator of equals, and we're going to say whenever our state is equal to 2, then we're going to do a one shot. So let's come back over here to bit, take a one shot. And I don't remember what the last one shot was that we used. That was one shot 6. So now we're going to have one shot 7. And we're going to create a trigger bit here, which is going to be our pump underscore trigger. So let's go ahead and create both of these new tags. Whoops, misclicked. I don't know what I clicked on, but it wasn't my tag. There we are. So now as soon as we go into mode 2, we're going to one shot and we're going to energize this pump trigger. And now I have something that's only energized for one scan, and I can use that to start my pump. Then I need something to disable my pump. So I need a pump interrupt. That's going to look like this. I'm going to create one more rung under here. I'm going to go back to my comparators, and I want my NEQ not equals to. So anytime I leave mode 2, I want one more one-shot here. And now I'm going to have my pump interrupt. So pump underscore interrupt. Got it? And let's go ahead and create those tags, and now I have a way to shut my pump off right here. That again will only happen for one scan, which is exactly what we want for triggers and for interrupts usually. And now I have a way to control my pump. So now, as one last piece before we wrap this lecture, we are going to go ahead and put in our controls for our valve. And that's going to look just the same. So I'm going to go ahead and copy and paste this rung, and I'm going to put it down here. And what is our drain mode? I believe our drain mode is 3. So let's come down here and say if the state is equal to 3, then we're going to have this new ONS 9 energized. Let's go ahead and create that. And that's going to trigger our valve. So let's go ahead and spell it correctly. Valve trigger. Right click that, new valve trigger. Good, we like it. Let's copy that and paste that right in here. And then we also need our interrupt, so I'm going to copy my NEQ rung, bring that down here, and say when we are not in state 3, let's go ahead and take our next one-shot address. That's going to be ONS 10, create a new one, and instead of being the pump interrupt, that's going to be the valve interrupt naturally. And we can right-click on that, create a new, and then let's copy that out of there and punch that right in here for our interrupt. So now we've got a way to start it, we've got a way to stop it, we've got a way to get into all of our different modes, we've even got a way to energize our devices. We're going to break for now, and when I come back we're going to set up our alarms. We've got our alarm modes for operation, but we don't have our actual alarm bits or notifications or a way to control them. So when we get back, we'll lay that logic out, and that should be the end of your refresher course in ladder logic.